All right, welcome to Unit 8. This unit is our logarithm unit, and the main thing that you need to take away or remember from this unit is that a logarithm, it's a fancy word. I know it's the first time many of you have heard it, the first time we've actually worked with it, solved them, graphed them, all this lovely stuff. But what you need to understand is a logarithm is really just an exponent. Okay, so we have two forms. When we're talking about a logarithm, we can write it in logarithmic form. And this is how it's read. You can read down here. We say the log base b. B is kind of a subscript. It's just a little bit smaller and lower than the log. So log base b of a is equal to x is how you say that. But you can rewrite this in exponential form, which is going to be very helpful for you for the rest of the unit, especially because you've been working with exponents for a long time. So exponents are a lot more common, that you've seen them before, so they're going to be a lot easier for you to work with them in exponent form. So when it's written in exponent form, you don't need the log. You're just going to have the b, the a, and the x. However, you have to pay attention to how you write those. B is the base. We say that even in logarithmic form, log base b. So b is your base. In exponent form, a base is raised to a power. So just make sure that it's on the other side of the equal sign. So if b is on the left, then you're going to raise it to what is on the other side of the equal sign, and it is equal to a. All right, so b to the x power is equal to a is how we write that in exponential form. Now, one other thing before we go through and start actually rewriting some of these in different forms is that we have a few logarithms that are that have some invisible numbers in them. So our first one is our common logarithm is log base 10. This one is very common. It's the easiest one to do. It's your calculator's programmed to do it. But usually they drop the 10. It's just an invisible. They will just write that as the log of x. Whoops, my computer is really funny. But log base 10 of x, they're just going to say that that is equal to the log of x. So there's an invisible base right there. That's the main takeaway that you need to get from that. Let's go ahead and look at this first example. This first example here, all we're going to be doing is writing each equation in exponential form. So we're going to go back. Let's see if I can make this pop up. We're going to write it from logarithmic form and switch it over to exponential form. So the first thing that you've got to identify is your base right here. Okay, so the base to the other side power is equal to that a, or 49 right there. And that's all they want you to do. It's already solved for you. 7 squared is equal to 49, but you don't need to do anything. You're just switching forms. Okay, let's try this next one, your base. Again, that's the most important thing. Just identify that base. So 2 to the other side power, the fifth power is equal to 32. Now, it's going to be helpful for you to kind of get familiar with these exponents, especially some of these over here that have exponent rules. But just remember, if you raise something to the second power, it's multiplying it by itself 2 times. So 7 times 7 is 49. This means you're multiplying 2 by itself 5 times. 2 times 2 times 2 times 2 times 2 is equal to 32. Okay, here's our invisible base. Can everybody see that lovely invisible base? Again, if you just have log of x or log of 1,000 right there, the base is 10. It's invisible, but there's a 10 right there. So 10 to the other side power, that third power, is equal to 1,000. And that's all they want you to do. We're just writing these in exponential form. All right, let's try this one. So my base is 4. I'm going to raise it to the negative third power, and I get 1 over 64. Now, you might have to recall from many months ago our exponent rules. Remember, if you have a negative exponent, what it really does is this just takes 4 to the third and puts it in the denominator. Makes it positive, but it's in the denominator. So this is really just saying 1 over 4 times 4 times 4. So that is a true statement. But just remember, if it's a negative exponent, you flip the fraction. This was just over 1, so you're going to put 1 and not 4 to the third in the denominator. All right, look at this one. My base here is 8 to the other side power. That 1/3 power is equal to 2. Now, this is a good one to look at as well. If you'll remember from our radical unit, well, I think that was unit 6, when you have a fraction exponent, the number in the top is the power. So this is 8 raised to the first power, but that 3 in the denominator, that's your root. That's saying the third root of 8 is 2. So another way to look at it, I always kind of look at it like this. If you're going from a bigger number to a smaller number, most of the time you're getting a bigger number. When you raise something to a power, you get a bigger number. If you're going to a smaller number, you can also just look at it from the smaller number and say, what do you raise 2, the number 2 to get an 8? Well, it's 2 times 2 times 2, or 2 to the third. So that's where that 3 comes in. It's the third root of 8 is 2 right there. It just works backwards. All right, this last one, my base here is 9. I'm going to raise it to the other side power, and it is equal to 27. Again, just remember this number in the bottom is a root. So this is the second root, or the square root of 9. Square root of 9 is 3. Then you've got to raise that to the third power. 3 times 3 times 3 gives you that 27. All right, that's how to rewrite things in exponential form. Our next video, we will write them in logarithmic form.